And our goal for today is to take what we've already done with equations and we're going to upgrade it to a whole new world of inequalities. So we're going to identify solutions of inequalities, and we're also going to graph and write inequalities. Eventually be solving and do something called compound inequalities as well. So let's take a gander at the very, very, very first one. Example 1a. The instructions here say, is each number a solution of 3 plus 2x is less than 8? And we'll get into some application of this in a little bit. But for now, we want to be able to play with the numbers. So we just have to take our value, which is negative 2, and that has to get substituted in for the x. So I'm going to place the negative 2 there. Of course, this whole time is technically a question mark. This whole time over here is a question mark until we actually come up with a straightforward scenario. So now I'm going to do my order of operations here. I'm not going to add the 3 and the 2 yet, but I am going to multiply the 2 and the negative 2 to get negative 4 or minus 4 in this case. Then 3 minus 4 is negative 1, and we see that this is a true statement. Negative 1 is less than 8, and what we see is that negative 2 is a solution. I'll do the next one real quick. We're going to do the exact same inequality. This time I'm going to substitute the 3 in because it says there. 2 times 3 is 6. 3 plus 6 is 9, and we see this is not. So my conclusion is that 3 is not a solution. So negative 2 is a solution, 3 is not. So all we did was just check one thing. There are an infinite number of numbers to check, so I'm not even about to keep checking. All right, real quick, I would like you to practice the AA. So look here, substitute the negative 4 in, and you can show the work underneath the negative 4. Go. So we see that AA there is a no. And take a look at how we can graph inequalities. Graph inequalities. Before, we didn't spend much time graphing a solution. For example, if I found that the answer was 35 on a particular problem. The graph of that really is just a number line with the number 35 in the middle, and then you just plot the point, there's my x. So it's unhelpful for us to plot the answer to or the solution to an equation. So what we're going to do here is that it is actually helpful for us to graph an inequality because there are so many options. We have an infinite number. So first off, as we are graphing these, let's remember when we have, and let's be specific over here, whenever we have the variable on the left side here. So x or d is greater than. Whatever the variable is, if it's greater than, then we're going to shade to the right because we go greater. Every number that's greater than 10 or something. And we're going to have an open point. And I'm going to say PT for point. So a quick way just to sketch this would be we just have an open point with an arrow pointing in this direction. All right, based on that, can you take about 30 seconds to conclude, what am I going to put in these other 6 boxes? Talk to your neighbor. You don't have to write anything. Just talk. Go. All right, and so notice if my variable, and I just put G here, if my variable is here, I'm going to shade left. Shade left. Remember, your variable has to be there, though. If the variable's on the other side, it actually changes the way it's managed. And here is going to be closed point, and so it's just a filled-in dot. Now to finish up over here, this one's going to be exactly the same as long as your variable is right there, but we're going to shade to the greater than direction, and we're also going to have a closed point. Closed point. All right, so let's look at number 2. So this one here says D is less than 3. So I go to the 3. It does not include 3, so it's going to be open point at 3. Now your book is going to, because it has the ability to have thicker lines and stuff, your book is going to do something like this, okay? However, it's a little bit difficult for us to do that with our pencils because they don't get fatter, etc. So I suggest doing this instead, is just make the arrow above or below, like in this manner, boop, going this direction. That's the fastest way. Plus, it doesn't actually end up interfering with any of the numbers here or any other points that you may have plotted. So we would graph it in that manner. Again, when you do the graph, notice on this graph, 0 is not right in the middle. It's so very tempting for us to say, oh, I'm going to graph d is greater than 3, and we always put 0 in the middle. You don't have to. In fact, I would put this one directly in the middle, and then you can shade on either side of it accordingly. All right, so the solution of d is less than 3 are all the points to the left. To the left of 3 on the graph. So as we look at the b here, besides being a different variable, which is insignificant, the variable is now on the right side. So if I wanted to use the rules as I set them up over here, I need to have the variable on the left side. So the way to do that, and remember, there is no symmetric property here. If I switch those two, then I have to flip that guy. So now g, and I now make it less than or equal to the negative 3. So like I said, there is no symmetric property of inequalities. If we reverse those expressions, we have to reverse the symbol as well. Now, you didn't have to do this, but for many of us, it probably is going to be helpful. All right, so we do see that it is a closed point at negative 3. Closed point. And we are going to graph everything to the right. If you completely forgot, you can always just do a quick check here. Notice here that 0 should not work because I didn't graph it. I didn't shade in to the 0 direction. So 0 should not work. So if I plug in 0 to the original 1, is it true that negative 3 is greater than 0? And that's false. Good, because I did not shade that. So anything over here should give you a false check. And I'm just going to write that in, not that you have to. But this will give me a false answer when you check it. And this one over here will give you a true situation when you check it. And that includes the 3 because of the closed point. And over here, the solutions of negative 3 are greater than or equal to g are negative 3 and all the points to the left. So it includes the negative 3. When you graph these puppies here, 1, take a moment to make it look clean. Number 2, I suggest putting this number just right there in the middle. And go 1 up, 1 down, or 2 up or 2 down. It doesn't matter. So I'm going to count 7 here and 5 here. So that's all the information we need for the setup. Then you actually do the graphing. Put an open or closed point and then shade in the proper direction. All right, on the next page, now we're going to go backwards to what you just did. We went from the situation, the actual inequality, to the graph. Now we're going to go from the graph to the inequality. So, quick thing to note is we don't know what the variable's name is, but they did give us over here the name of the variable x. So, when you don't know the variable, you choose whatever letter you prefer. Now, we see that it is an open point, so I'm not going to have the equal to, and clearly I'm going in the less than direction. So, x is less than simply 2, and that's it. So my answer would be this: x is less than 2. That's what I'm going to write down. And there's no work to show at all. It's just a quick identification. The numbers less than 2 are graphed. Or you could say to the left of 2 are graphed. We have a closed point right there. Also going in the less than direction. So closed point means I have the equal to. Less than symbol there, and I'm going to use the number negative 3. So there's my answer for the graph. X is less than or equal to negative 3. That's my inequality. So the numbers less than or equal to or equal to negative 3. And of course, in real life, we have situations where you can spend a certain amount of money or the temperature drops below or above something. So we're going to define a variable. In other words, T means temperature. A means my age. So it doesn't have to be, it can be X every single time if you want. But it's always nice to have it cleaner. And then we're going to write the inequality to model each situation. The temperature in a refrigerator truck must be kept at or below 38 degrees. So I'm just going to put here I'm going to call T for temperature. Wow, way to throw me for a loop. Must be kept at or below. At or below is clearly going to be less than or equal to. So T is less than or equal to 38 degrees Fahrenheit. And we can leave it in pure math without the unit here. So we'll walk through this one. On number 19, what variable did you use? And are equal to 2,000 pounds. So one thing we always need to check, it says the maximum weight. Does that include 20 or 2,000? And the answer is yes, it does, because maximum is it could get up to without causing any harm.